Hello friends, welcome to the next video of Java online course. We are in exception handling. So in last video we have started with the exception handling mechanism of Java. We have seen the try and catch, how to handle the try and how to handle the catch for arithmetic exceptions also. And the last program that we have seen, it was generating the exception rather than the arithmetic exception. Its exception was array index out of bounds exceptions. Okay, so now it may be possible that a Java program can throw multiple number of exceptions. Then in that case what we are going to do and what operations are expected, that we will see. So in this we are going to see multiple keywords now, multiple catch, nesting of try. Then we are going to see how to use finally block, how to use throw keyword, how to use throws keyword, and how to create your own exceptions also. So let's see the program, what we are going to do in that situations. Okay, so here I am creating a multi-catch program. So from where we enter the number from the user here, so that number may be anything. Okay, so it's storing in the variable x, correct. So three variable are declared x, y, z, reading the number, storing in variable x, taking from the user input. And now in the try block, see the try block present here, I am dividing 50 by that number, whatever number is that, I am dividing this number. So maybe that number is 0, this statement will generate an arithmetic exception, or if it is not 0, it will print the division on the screen. Once this is done, I am declaring an array with 5, 7 and 8. 3 numbers are present inside it. Okay, so that 3 numbers I am declaring, I am storing inside the variable arr. It's just an array. Then after that I am printing at 10th position 120, which similar kind of operations also we have done in the previous video. Because of that, array index out of bounds exception has occurred. Now array index out of bounds exception is actually generated. Why? Because the arrays value are you storing inside the index, which is not within the range. So only 3 index are possible here in this case. 5, 6, 5, 7 and 8 means 0, 1 and 2, and I am printing at 10th location, means that index is not present. That's why we are going to have the error exception over there. Now here I am ending the try. Now this is the solution that I can have when I am going to have the multiple exception occurred over here. Now catch arithmetic exception. So when arithmetic exception is generated, I can execute this particular catch, and when array index out of bounds exception is generated, I am going to use this particular catch. Okay, so let's try that. Division by 0, and here I am writing array indexing is wrong, and if none of the error has occurred, we are going to print the program ended. Okay, so that's how we are going to make use of it and perform the operations respectively. Okay, so what I'll do, I'll make it more concise. So let's make it x here. So value you enter from the user, at that location I am storing 120. Okay, maybe it's 0 or maybe it's non-zero. Okay, check it out. Okay, so program is ended. This is what we call as multi-catch statement. A try can have multiple catch statements also. We can specify what different kind of exception expected to get outputted from the try. So that number of exception classes we can write inside the catch after the try. Okay, so wherever the exception is matching, there will get the output printed on the screen. So whether array index out of bound exception or the arithmetic exception divided by 0 is there, based on that your catch will be executed. So let's run this. So enter the number. For example, I am printing 6. Division is correct, but at 6th position I am printing storing something, which means array index is out of bounds, indexing is wrong. That's why array index out of bounds exception is caught, and I am getting this on the screen. Okay, now if I run this again and if I enter 0, see now division by 0 has occurred because of this statement. This has occurred and it's printing it. So at a time only one exception will be generated, because when it's generated, it's executing the catch statement of it. So catch is executed only once. Out of all multiple catches I can execute, I can have printed only one catch on the screen. So this is how one catch is printed. And in third case, so let's say our third case is very interesting. Sorry, not this, let's run that. Okay, so 3, okay, not 3, 2. 2 index is also possible, and divided by 2 is also possible. See, division is 25 and the value is printed there, try is ended, and program is also ended. That's it. So here we didn't get any output. we didn't receive any exception, sorry. So because x of 2 is printed, because x of 2 is present here, instead of 8 I am going to have 120. Try is ended, no exception this, no exception this, and program is ended successfully here. Okay, so this is how multiple catch statement we can write, but again maybe different problems are there, that also we'll discuss. But let's go for the next concept of exception mechanism. Here is to nest the try blocks. So let's see, nesting the try block is possible. Let's see how to nest it. Okay, so a try inside another try is possible. So in this particular program, same program I carry forwarded from the previous example, and here I have added a try inside a try. So this is outer try, which is there for arithmetic exception catching, and inner try is there for array index out of bounds exception catching. Okay, so here if array index out of bound exception has occurred, then it will catch this, and in the whole block if arithmetic exception has occurred, then it will catch this particular part, division by 0 will be printed, and if none of the things has occurred, then will come out of the program, and program end will be printed only, and all operations will be executed perfectly and completely. So here this is what we are having, the arithmetic exception present over here at this location. Okay, here we are having this, so let's create it more significant. See, and here I'll write x. Okay, so try can be written inside another try. Its output is almost similar to the previous one, but what I done, outer will look for the arithmetic exception and inner will look for the array index out of bound exception. That's what the main difference that we are having between the previous program and the this particular program here. Okay, so let's run this. Okay, so first number 12, second number is, okay, number is 12 divided by array indexing wrong, because 12 I am clicking over here, that's exception is caught here, it is catching this only. Okay, and in second case if I enter number 0, so I will get division by 0. So here I am getting the error, so it's terminating directly from this location and executing this particular party. Fine, but if I am having this exception here in this line, array index out of bound, then array index out of bound will not be caught, because it's there inside this try only, it will not look for this try. Fine, so try inside a try is also possible, but very rarely we use it in the programming. So but nesting is possible, any kind of conditions, or you can use the try anywhere, like in if else, we can use in switch case, we can use in for loop, while loop, do while loop, or in any methods, anywhere we can write this try block to monitor for the exception occurrence inside the program or inside the Java statements. Okay, that's what we can make use of it here. Fine, so this is how the exception handling mechanism, common exception handling mechanisms of Java works. Now let's write a small changes in the program that we have seen already. So here we are using nesting, sorry, just a minute, exception handling methods. Okay, which was the program that we have seen. Okay, exception in methods. Okay, yeah, this one, or we have multi catch. Yes, I'll make the changes over here. What changes? So let's use try end, and let's write error of -6 is equal to 78. Correct? Now what do you think, what will happen? Okay, something weird always I'm writing in the program, maybe it's supported or not supported by the programming language. So let's run this, we'll make it 2. Okay, array indexing is wrong, shown over there, array indexing is wrong. So here this second position I'm printing 120, then try is ended, and this has generated the indexing is wrong over there, that's why the error is generated. So what I'll do now, I'll make a small change here. This array I'll declare, okay, array of like -6, okay, and then we'll perform some operations onto it. ARR of x, okay, just a minute. Okay, this is ended, variable ARR not initialized. So see, if you write the minus symbol over here, showing error. So 6 number of elements, you can try that. Okay, what is expect a short array. numbers we need to write. You have to perfectly write the program over here. So let's have int x is equal to new int, and till 10 elements we can specify here. The variable, okay, x, sorry, already initialized, and so this is y here. Okay, that's completed. So every time I'm using different variables available there. W, yes, W is not used. Okay, so let's use this. So that's what I do, -6. Okay, so I'm writing this here. Let's run this. 2. Now check, my output is different now. So arithmetic exception and array index out of bounds exception, both are not occurred. We got another different kind of exception, that is called as negative array size exception. Now array size is, it must not be negative. It's possible that we can have the integer value as array size, but it should not be negative. That's why the output is generated. Then what to do on that? One small and common practice many programmers uses. See, Java is having a exception hierarchy. It's a class exception hierarchy. In the class exception hierarchy of Java, we are having one super class that is called as the exception class. Now exception is a super class of all the exception classes. And now let's revise the property of inheritance. Superclass object can refers to any subclass object. Superclass reference variable can store any subclass object inside it. Now let's catch the exception by using the top variable, top object of exception here, and let's get the message why the error has occurred. E dot get message. See this. Now by this method we can see why the error has occurred. See, it's showing null printed there, program is ended, and here the problem with this particular line, I'm going to print this message on the screen. Why? Because of this. If I write the comment inside it and I'll run this particular line, and let's try 0. See, divided by 0 is printed, program is ended. It means that I have not caught the array index, out of bounds, or arithmetic exception. I am catching the top level class there, the class which is present at the top level. That class I am using here, and I am getting different errors now. So here, if I run this code again, check it out, I am printing 2. Now my output is null, program is ended. Okay, so output generated is null, it's printing that particular message. 25 is the result that we are getting over here, and the output which is printed by here is null. So exception class I can write to catch all kind of exceptions. Okay, every kind of exception can be caught with the help of the exception catch, exception clause, class, and will print that message on the screen. So exception can catch all kind of exception which are the subclasses of the exception class there. So this mechanism also we can use, and if you want to print why this exception has occurred, we can use e dot get message to print that message on the screen. That's how it will work. Now let's go for the next finally clause. Try and catch are connected with one more keyword called as finally. What do you mean by finally? So finally is the clause connected to try and catch, which is executed always whether exception is occurred or not occurred. In both the cases, this particular block will get executed. So let's try this one, how the output is generated. So in this particular program, I've declared int val equal to 0, im is equal to 100 divided by val, and then arithmetic exception we are catching here. Okay, so if exception is occurred, that will print this exception why it's occurred, and if exception is not occurred, then it will go for finally. It means that from both the cases, exception occurred, final block is executed, exception is not occurred, then also final block is executed. So basically, when in program you have to do the shutdown activities like closing a file handle, terminating the database connections. Okay, so these operations we can do inside the finally block always. So let's try this particular code, so you can check it out. Try, this is a try block, this is the catch block. Okay, so try, we'll try for this division by 0. If it is occurred, exception will be printed, and finally will also get executed. So let's try that. See, exception by 0, this is printed, exception is occurred. Okay, so catch is executed, final also executed. Now if exception is not occurred, now let's try that, because now I am making it 4, and 100 divided by 4, it's written in try, exception will not occur. In that case also I will get the finally executed there. So finally is a special kind of the clause, special kind of the block connected with the try and catch. It is executed upon exception is occurred or exception is not occurred. In both the cases, the finally is having the execution in the program. So when you have to do the shutdown activities, we need to make sure, we need to remember that this shutdown activity should be entered inside the finally block. So see, finally was connected. It's a keyword which will contain the statement will always get executed upon the exception occurrence or not occurrence. Okay, that's how we can make use of the finally clause here. Now two important keywords that exception handling is containing here are throw and throws. So let's go for the throw first. Throw is a keyword. Now it's very interesting to see this throw keyword here. The throw keyword is to throw the exception manually from the program. Manually, when exceptions are not occurred, then also you can throw the exception from the program by the help of throw. So let's try that. Check it out. Here, so two variables I declared, x and y. I am making addition, and then after that addition I am throw new object of arithmetic exception with this particular error message, divide error, throw it. So that will throw, and here I am going to catch it, and I will print that exception on the screen. I will print the addition also on the screen. Now throw is manually throwing the exceptions from there, and it is compulsory that this throw statement should be returned inside the try block. Then only catch will catch it and perform the further operations on this particular object. So let's run this. See, java.lang.arithmetic exception, divide error has occurred, addition we got 30. Okay, because manually we are throwing this. Any kind of such exception you can throw and you can catch it. But this is throw statement is not basically created from that intention. It's created to create your own exception. That's what the meaning of throw is actually. I'll show that after one more block called as throws. I'll show how to create your own exceptions. When some conditions are not defined in Java's internal API's exception API hierarchy, then we can create them by your own, and that user defined exceptions can also be used in the programs of Java. Okay, so check it out. Throw is just to throw the exception manually from the program. Okay, now let's go for the throws. Throws is also very interesting concept. So program is very small. Okay, now what throw is? Look at clearly. There are two kind of exceptions that Java programs are containing. One is called a checked exception, second are the unchecked exceptions. Some methods, some user defined inbuilt methods of Java's API are containing ability to have an exception within them. They contain the ability to have an exception within them, means is a possibility that exception will occur when you call these methods. It's a possibility here. Now let's look at that. I'm having one method here, thread.sleep. Okay, so sleep method is used to add the sleeping time in the output. So let's see this. I'll just show this as out and hello world. So before printing hello world, program will be sleep for 3000 milliseconds, and then it will print the hello world. But you just see the error is shown over here. Unsupported exception, interrupted exception must be caught or declared to be thrown. It means that this particular method is having ability to have an exception within it. So while using such methods, we need to write them inside the try and catch block. Okay, in this way, catch exception E and done. Okay, now we'll have the correct output. Okay, so if I run this code, okay, if I run this, I'll after 3 seconds I'll get the output. Check this. Yes, got this hello world. So but if I want to use this method, I need to add this try catch also, because manually there's a possibility that this method is throwing the exception. Such many methods that Java's internal APIs contains. So for every method you have to write this try and catch block. But one thing, I can override this. I don't require this, but still the error is present. So what to do? There is a method by which you can write it. So the method which calls that particular object or methods, you have to write throws clause there, which throws exception, exception. Okay, now the error is removed. This throws clause used to throw the exception out of the method directly by this mechanism there, and now the exception will not occur in this particular program. They are thrown out of the method itself by using the throws clause, and now if I run this program, I'll have the similar output. 3 seconds and now output. Fine. So such many methods are present in Java's API. You have to look for the syntax or signature of these methods in the documentation, and after that only we can see which exception that they are manually throwing, that is checked exception that they are throwing. Only that exception we can write in the throws clause. So throws, and that exception name you have to specify. Here I am throwing all the exceptions, all the checked exceptions from there. I can write throws IO exception, throws interrupted exception, throws SQL exceptions. Okay, that we need to specify. See, in upcoming sessions also I'll show the meaning of these throws again, when it's required and when it's not required. Okay, so throws can't throw all the exception. Only possible exceptions can be thrown. Arithmetic exceptions can't be avoided. Remember, array index outer bound exception can't be avoided. Avoiding exceptions are not possible. Possible exceptions can be avoided. Okay, so that's why you have to remember. It's a part of practice actually. So remember that. What's the use of the throws clause over here? And now let's come with the last part of this particular video, is to create your own exception. Okay, creating your own exception. So whatever we have seen, all finally clause is used to execute the statement which whether exception is occurred or not occurred. Throw clause is to throw the exception manually by own, and throws clause is to throw the exception out of the program which are checked, where the possibility of exception are there, that can be thrown out of the program by using the throws clause. Now let's go for the last code, that is creating our own exceptions. So some conditions may not have been defined, inside the Java's API or exception hierarchy. So such exceptions we can throw, or we can create them by our own, and then we'll throw them out of the program. So how to do this one? With the help of exception inheritance, we can use this. How to do? Class negative output exception. This is the class I am creating which extends the exception. Now when exception is a default class of Java, in java.lang package is defined, I am inheriting that class in my own class, that is negative output exception. Okay, now what's the advantage of it? Now my class contain ability to work as an exception here. Okay, so inside it I am declaring one constructor negative output exception int a, and giving this variable to date, that's like a message, and I am overriding one more method from object class, it's called as toString. It means that if I am printing this negative output exception on the screen, what message should be printed, that I am giving over here. Okay, that means it's a value because of which negative output exceptions occurred. It means that when output of the program is negative, then I am going to create this exception. I am going to throw this exception in my program. So let's try that, how to do this one and how to perform the operations on this. For this particular program, I am taking the data from the command line. Argument number 0 is first parameter, argument number 1 is second parameter. Okay, then I am clicking z. So z is equal to x into y. Okay, I am multiplying these two numbers together, first and second, and then z is equal to x into y. I am multiplying these numbers, and after that I am generating a result. If that result is less than 0, then throw new negative output exception set. Z is the number because of which the negative output exception has generated, and if it is not generated, then I will print the multiplication of them on the screen like this. And thrown object or thrown exception, I am going to catch over here, catch negative output exception and print what we have caught in this particular way. But in order to run this program, so check it out how the exception is created. I am extending the exception class, then it will contain ability to work as an exception, so throw can throw it. Okay, and toString means when you print the object on the screen, what should be printed? Negative output exception and the number will be printed. That's why this toString method I am overriding over there. Correct? Fine. And here I am passing the argument from command line. So this command line argument I need to specify here first in project properties. Okay, let's pass this here. Run. My main class is what's that? Let's browse. It is own exception basically. Own exception is my main class. I want to pass argument 12 and 7. Okay, 12 and 7, two arguments I am passing, and let's run this. See, 84 correct output I am getting, because these numbers are multiplied and I am not getting any error or exception over here, so I am getting this output. Correct. Now let's make the changes there. Change the inputs. Okay, because command line arguments are there. So let's run. 12 and minus 7. Two arguments I am passing. Okay, let's run this. I am parsing them. Now let's see. Negative output exception minus 84. Okay, so this value negative output exception is generated said. I am putting it said over here. This value I am storing in det, and when I am printing, that is printing over here to string. When I am printing it here, exception is caught, and that exception I am printing as it is on the screen by this particular mechanism. So when some conditions are not specified as an exception in Java, we are allowed to create your own exceptions also. The thing that we have to do here, we have to create your own class by inheriting the exception class. Once it is inherited, your program will contain ability to run an exception, and then we can create a constructor of it. We can redefine the toString method over there, and after that, when upon which condition you have to throw it, that condition you have to specify, and then throw the exception, then catch it, and further perform the operation of handling it. So it's again not required to have the negative output exception written over here. You can write only exception also, because again superclass reference variable can store the subclass object. Okay, so if I run this, array index out of bounds exception I am getting here, not this. I want to run project. Okay, so negative output exception 84. So command line arguments I am passing, and this I am taking over. One more thing, so if I pass the negative numbers from the command line, so minus 12, because negative into negative, the value will become positive, and when I run the project, 84, correct. Negative output is not generated. It means that when any one of these number is negative, that time I am generating this particular exceptions. So it completely depends upon your applications, where you are going to apply or make use of these particular concepts much effectively to handle the exceptions. So exception handling is very common mechanism used in many advanced Java technologies. So if you want to focus on advanced Java technologies, make sure that all the concepts of exception handling are clear, and how they are used, what are the applications, what are the properties, what are the differences that they are having. Try to remember it, try to practice it. The programs are given to you. You can try that and check the output of them. Thank you. Thanks a lot.